All right, so let's see what happens here. I'm going to create my matrix: 1, -1, -2, 5. Okay, 2, 2, 1, 1, 1, 3, 3, 10. Okay, now the one thing I see here is I'm always very happy when I see a 1 in that top position. If you take a look at the next question, there isn't going to be a 1 at the top position. What do you think I'm going to do in that circumstance? What did we say was one of our, there you go. I'm going to rearrange the rows because that's one of my elementary operations. Because the whole thing about working with matrices, and this is again much more important when you're getting to much larger matrices, is to keep a consistent algorithm. So even if if there's no way to get a leading 1, you're going to divide that row by whatever number it is, and you're going to start with this leading 1, because it just makes things a whole lot easier to work with that leading 1. So I would say for a 3x3 scenario, 3 equations, 3 unknowns, you can easily stop at row echelon form. Once you started to get to 4, especially 5 and above, you probably want to go all the way to reduced row echelon form. Okay, so again, because this is a very small number of equations, it doesn't really matter which way you go. Okay, when you're working with many more equations, you probably want to go the route of reduced row echelon form. Okay, so here it's following an algorithm, same thing every time. It's going to be -2r1 plus r2 replaces r2. -r1 plus r3 replaces r3. Okay, I don't even think about it. I just eliminate these two numbers here. -2, 5. Okay. -2 plus 2, 0. This is going to be 2 plus 2, 4. This is going to be 4 plus 1, 5. Okay, this is going to be -10 plus 1, -9. Okay, please check my algebra as I go, of course. Okay, -1 plus 1, 0. This is going to be 1 plus 3, 4. This is going to be 2 plus 3, 5. This is going to be -5 plus 10, 5. Now, I'm just going to keep going. I'm hoping you're already seeing where this is going. Next step is to eliminate this value here. So I'm going to do -r2 plus r3 and replace r3. And let's see what that gives us. Row 1 doesn't change. 1, -1, -2, 5. Okay, 0, 4, 5, -9. Okay, -0 plus 0, still 0. -4 plus 4, 0. -5 plus 5, 0. 9 plus 5, 14. And what's the issue? What does this represent, the 0, 0, 0, 14? What is that telling us? It is telling us row 3 is claiming that 0 is equal to 14, which is a contradiction. And so what's our conclusion? Given that we assumed there was a solution and we came out to a contradiction, what is the conclusion based on that? There you go. I agree. It does seem even more, kind of puts a more oomph to it when you say it in French. Okay, no solutions. Now, if I were to ask you to give a geometric description of what's going on, well, you know, oh, I've got 3 planes, none of them are parallel, there's no solution, hence, what can I say geometrically here? What scenario would this represent if I have no part, the triangular prism? Now, here, all they asked us to do was to solve the system of equations. So here, that's all I have to say, is that there's no solution. But if they're asking me for the geometric interpretation, okay? So this was, I forgot whose question this was, is what happens when there's no solution? Well, it's the same answer as always. The algebra will take you there, okay? the algebra will do its job. Okay? Okay. And what I want to try to do here is I want to try to do this quickly. I want to try to, like, I'm going to sort of talk it out. You'll hear me talking it out. But in order for this to be useful, you have to become quick at it. Practice is the way you're going to do that. Okay? So 1, -2, 3, 1. Okay, 2, -3, 4, -2. And then 1, 0, 1, 7. Okay? So always doing the same thing. Negative R1 plus R2 gives me R2. Negative, of course, that was supposed to be -2. And then negative R1 plus R3 goes into R3. Okay, 1, -2, 3, 1. Okay, -2 plus 2, 0. Okay, 4 minus 3, 1. -6 plus 4, -2. And then -2 minus 2, -4. Okay, so here, -1 plus 1 is 0. 2 plus 0 is 2. -3 plus 1 is -2. And then -2 plus 7 is 5. Okay. -2R2 plus R3 into R3. 1, -2, 3, 1, 0, 1, -2, -4, 0. So -2 plus 2, 0. 4 minus 2 is 2. And then 8 plus 5 is, I feel like I made a mistake here because I don't think this is what the answer should be. So let's take a quick look at at my answers here. Okay. -2 plus 2 is 0. This is 4 minus 2. Row 3, 5 should be 6. So let's take a look. This one here, what did we have? We had -1 plus 7 is 6. Good catch. Thank you. Who was that? Andrea. Good catch on that. I was pretty sure I picked nice numbers for this one here. Okay, so this ends up being 8 plus 6 is 14. Okay, and so from here, I could solve 2z equals 14 and solve that way. But just for the fun of it, let's keep going to do reduced row echelon form. So first thing I'm going to do is I'm going to do 1/2 R3 into R3 just to make this nicer to work with. 1, -2, 3, 1, 0, 1, -2, -4, 0, 0, 1, 7. Okay, so right off the bat, I know that z equal to 7 is one of my answers. Okay, so let's eliminate these two. So what do we have? We have -3R3 plus R1 replaces R1, and then 2R3 plus R2 replaces R2. So I can eliminate those two. Okay, so what do we have? We have 1, -2. Okay, -3 plus 3 is 0. Here we have -21 plus 1 is -20. Okay, 0, 1. Here we've got 2 minus 2 is 0. And here we've got 14 minus 4 is 10. And 0, 0, 1, 7. So there we go. Y is 10. There's another one of our answers. And let's do the last step. 2R2 plus R1 replaces R1. Okay. Well, maybe you made a second mistake to cancel out the first one. Okay. So here, where are we at there? This should just be 2. 2 minus 2 is 0. That's just 0. And then here we have 20 minus 20 is 0. And so here 0, 1, 0, 10. 0, 0, 1, 7. So we have x equals 0, y equals 10, z equals 7. Okay. So, fair bit of writing. Okay, like I said, you will undoubtedly, if you take a linear algebra course, you'll have some nightmares doing 4x4, 5x5 of these matrices, and you're going to have to be exceptionally careful and second guessing yourself throughout. Okay, but in the end, this is a very compact way to deal with multiple equations and multiple unknowns, especially when you go beyond 3.